my screen?
Not yet, not yet.
Okay. Yeah, I think Google Meet have limit the time of usage to, I think, 1 hour or so. So probably if our class end, if the link terminates before our time, I will just recreate another link and then send it to you guys so that we can continue from there. So, but I think they've limited it to 1 hour. So, but if you need more than that, I'll just create another link and send it. So even if this link terminates, please don't go offline. I'll quickly create another one and then forward it to the group very quick so that we can continue. Okay, so I wanted to just continue from where we stopped, but then I just looked at it and said, well, it won't really be that good because probably some people must have even left some of the things that we did. Some may have gone through, some may have not. So the best way is for us to kind of like just a quick refresh on some of the things that we've covered and see how we can actually recover, let's say, some of the knowledge that we've gained or lost. So one of the first things we'll start with, let me bring out my notepad. So one of the things we talked about, like I said, we are learning machine learning currently, and we said machine learning is actually splitted into, basically we looked at it in 4 parts. So if you want to actually get a full understanding of that, you should go to sklearn models map. So yeah, choosing the right estimator. So the thing is, most times in data science or machine learning, they use different kind of names for the same thing, different names but the same thing. So if you hear anything like machine learning model and you see something like estimator, they are the same thing. So a model and estimator, or you see algorithms, so they are just basically they are referring to the same thing. So don't be confused about that. They are referring to the same thing. Then, so let's look at what we are trying to explain here. So if you look at machine learning models are actually, or machine learning itself is broken into kind of, we'll look at it in like 4 or even 5 ways. So you have a situation where you have to work on a model that will predict whether something is good or something is bad, or whether something is a cat or something is a dog. Now in this case, when you are working on things like this, we call them category. You're working on things like, hope you can see my screen. Hope you guys can see my screen and you can hear me.
Yes.
Okay.
Yes.
Okay, good. So when you're working on things like this, we basically refer to this type of machine learning model as a classification model. So you can call it a classification model or estimator. Remember, like I said, model and estimator is actually the same thing. So good or bad, cat, dog, pass, right, and fail, anyone, either A, and it could be more, either A, B, C, or D, just like the grade, So when you do something like this, it is a classification. What you are going to use is a classification model. So the first thing to picking a model is to ask yourself, what problem what problem are you trying to solve, or what problem are you solving? So if that model is to predict whether something is good or bad, it is a cat or a dog, it is pass or fail, it is among this category, then we refer to it as a classification. In this case, the problem will now be a classification problem. It will now be a classification problem. So if you are dealing with a classification problem, you know that the model you have to use is a classification model, or a classification estimator. Are you getting? So I think we discussed this too in our previous classes, so we are just taking a refresh. But then, if what you have to predict is actually a number, now sometimes when we say number can at the same time fall as a classification problem. Why? Because probably, let's say, you could be dealing with like a number, let's say doors of a car. Now, either a car will have 4 doors, right? Or it will have these trucks, how many days to have? I think either 4 or 2, yes. So either a car will have 4 doors, or a car will have 2 doors. Now in this case, it's still classification. Why? Because even though it's a number, it's still classification, because it falls between a particular category. So either 4 or 2, so it's still category. So like a normal car, we have 4 doors, right? Then things like trucks, we have just two doors. So it's still a classification problem. So the model you use for this is still a classification model or estimator. But the number we are referring to here now is numbers like a continuous number. A continuous number. There's no breaking in between. Let's say you have it is 34 and something. The number is from, let's say, a range. Let's say a range of number. Let's say from 30 to, let's say, 100. And in this case, it is no longer a classification problem. Now, what you are facing now is what we call a regression problem. What you are trying to solve now is a regression problem. And the model you use in solving that problem now, you call it a regression model or estimator. So, get the difference. So, an example of this will be like somebody's salary. So, you are predicting the salary in a company. So, if somebody is a CEO, how much is the person expected to have as their salary? Or if the person is a manager of the business, if the person is a secretary, what's the salary range? If the person is a cleaner in the organization, what's the salary range? So in that case, it is a continuous number, because either one person will be collecting, let's say, 50,000 a month, another person will be collecting 150,000 a month. So that's the range of numbers. It is continuous. So in that case, it is regression. So what you are trying to solve there is a regression problem. And the model you use is what we call a regression model or an estimator. Then you have other problems like now these two, classification and regression, falls under supervised learning. It falls under supervised learning, and if you recall, let's go to this place. Supervised learning. So remember, we are just trying to refresh some of the things that we've learned previously. So supervised learning, also known as supervised machine learning, right, is a subcategory of machine learning and artificial intelligence. It is defined by its use. This is what you need to have in mind. Its use of labeled data sets to train algorithms. Remember, like I told you, even if you see algorithms, it's the same thing as the estimator, it's the same thing as model, and it's the same thing as algorithm, still referring to the same thing. So by its use of label dataset. So when we say label dataset, an example that they've given here, you can see you have, let me see if this can expand. And you can see you have different shapes here, and these shapes are labels. So when we say labels, it means that every single shape has a name. So this is a hexagon, it is named as hexagon. This is a triangle, it is named as triangle, and this is a square, it is named as square. So this type of data set that has their name, so if you have if you have a particular height, you can say, okay, this height is for female, this height is for male. So that type of data set is labeled data set, and it falls under supervised learning. So remember, supervised learning, its use of label dataset. It's just like you are given the system expo. You already have the answers available. Yes, Daniel, you raise your hand. Yes, go ahead. Hello, Daniel, you raised your hand. Is Daniel there?
Yeah, sorry, I can't. I was
You what?
like the network was breaking, so I had to.
Okay, all right. So let's go back to where we was, right? Okay, by its use of label dataset. So it's just like you are given expos already. You already have all the answers to the questions ready and prepared to be given to the system or to the model. But now, so the supervised learning, you have those two categories. So it could be classification or regression. So you have the answers available. But you have another type of learning, which is unsupervised learning, which in this case you only have data sets. They are not labels anymore. You can see it uses machine learning algorithms, that's model, to analyze and cluster, you can see, unlabeled data sets. Unlabeled meaning the answers are not there. The answers are not provided by the data set. So all the data sets, what the machine learning models will do, okay, let's use this image as an example. If it were to be a supervised learning, all these fruits will have a label assigned to them. So like this fruit, the red one now, you have a label assigned to it as apple, and you have a label assigned to this as banana, orange assigned to this. Apple will also be that, and watermelon will be assigned to this, and this should be, is it Irish or orange? Where is it? Yeah. So if it is supervised learning, labels will be assigned to this. So if it's supervised learning, labels will be assigned to all of this. You get what I'm saying? So they will have labels assigned to it. But then, if it is unsupervised, remember, unsupervised learning, then you can see that there is no label assigned to these fruits. That is, their names are not given to the machine learning model, or their names are not given to the model or the estimator. So what the model will do now, the model will look at all the data sets and try to just separate the ones that look similar. So it will try to group them, and that grouping is what we call clusters. So the model just look at all the fruits. Remember, they don't have names, and then it will separate them to the ones that actually look similar, and that is what you see the model doing here. And so you have results. You can see it has grouped this, and this one is only one, and it has grouped this one because it still falls under orange, and this still falls under apple. But in this case, it is unsupervised learning, the labels are not provided. I think, yeah, this one also is a very good example. Can you see? So we give it this data set. You can see pictures of apple and watermelon. Send it to the model, and the model groups them. That grouping is called clusters. So you can see you have apples up and watermelon down. That's what unsupervised learning does. Are we clear on the difference between unsupervised learning and supervised learning, or unsupervised machine learning and supervised machine learning? Okay.
Yes,
Because you need to actually understand that very well, because you've had some interviews for, let's say, entry-level data scientists or machine learning engineers. They just want to understand. They just want to know if you can actually explain to a small child the difference between those two type of machine learning. Then, since we have supervised machine learning, right, and unsupervised machine learning, it is now broken down into different aspects. The supervised machine learning is now grouped into classification and regression, where we said classification deals with predicting a particular set of category. Is it a cat or is it a dog? Whereby regression deals with predicting a continuous number, like the salary of for a particular employee in an organization. Why unsupervised learning is also grouped into two. Unsupervised learning is also grouped into two. You have clustering. And remember what I said, clustering is that grouping of similar objects is called clustering. And you also have dimensionality reduction. So dimensionality reduction, what it does is the model goes in or takes a particular data set. If you recall, there was a data set I gave you guys for a project, that's in our last class, that it has a lot of what they call it. It has a lot of features. Yeah, a lot of columns were there. I think up to like 27 or so, if I'm not mistaken. So that 27, most times, if you want to use those 27 features to train a model, your model won't be able to learn well because it has too much features to learn from. So it will have difficulty actually gaining insight from that data set. So what you do is you can use a clustering model to kind of like reduce the number of features, hence the name dimensionality reduction. So you reduce the number of features that are available, or the number of columns that are available in that data set, then you can now use it to can you mute yourself? Okay, so that was right. So most times you use the model for dimensionality reduction model to reduce the number of features that you have. So if you have up to like 27 columns, when you apply dimensionality reduction, it will kind of like reduce them to like 10 columns. So in this way, your model will be able to learn very well, or learn much better than having to go through 27 columns. So that's what we actually use dimensionality reduction to accomplish. So the summary of the whole thing is that we have our machine learning models. So we call them machine models, or we call them estimators, we call them algorithms. It's still referring to the same thing. and it's broken down into supervised learning, supervised learning, supervised learning, then unsupervised learning, right? Then, and so we have another one, reinforcement learning also, but we won't be covering reinforcement learning because it's a whole different job on its own. So in the supervised learning, we said you have two types. You have classification, right? You have classification and regression. You have classification and regression. Why clustering? Sorry, why unsupervised? You have clustering, and you have dimensionality reduction. You understand? So remember, in fact, most of the problems you actually face are within these two fields or within these two types of machine learning. Either you face a supervised learning problem or unsupervised learning problem, and then you decide, is it a classification problem or a regression problem? If it's a classification problem, you pick a model that deals with classification issues. If it is a regression problem, you select a model that handles regression problem. If it is a clustering problem, select a model that handles clustering. And if it is dimensionality reduction, you select a model that deals with dimensionality reduction. So if you understand that, then you are very much good to go. So another good tool you can use is sklearn map. So in fact, before I even talk of sklearn, I want to give you guys some hints, because the idea behind this section is that it's for you to have enough knowledge and how to actually get resources that you can actually build things on your own without having to wait for anyone to come and then teach you or anything. So you have, let's say, basic libraries. Remember, I think we talked about this before. Talked about libraries. Talked about we have libraries, and these libraries, we call them modules, and some people call them packages. So whichever one is still referring to the same thing. Now you have to know which one you can use for whatever project you are trying to run. So if you are running a project and you actually want to visualize, let's say for visualization, you want to look at things, you want to do some analysis, let's say you just show some visuals, you know the right you use Seaborn or you use Matplotlib, right? Those are the two visualization packages that you use. And if you want to just manipulate, let's say you want to manipulate a data set, a type of data set, the models that you use is just basically two, pandas and NumPy. There are other ones, but these are the well used and very popular ones that you can actually use for your project. Then when it comes to model development, because this is one of the important ones, when it comes to model development, remember the model, like we said, you can call them estimators. When it comes to model development, that's when you are now ready to develop a machine learning model. You have three popular packages that you use depending on the problem you are facing. One of them is sklearn. This package contains all the models that you will need, whether it is a supervised learning problem or project, or it is unsupervised problem. You can use sklearn to do virtually all of this. So if you just go to, if you type sklearn, on the side, not sklearn, type sklearn. You can say sklearn is a free software machine learning library for Python programming. So it contains all the machine learning models that you need. Then if you want to look at all the models that are available, if you type sklearn models map on Google, the first link that you see, choosing the right estimator, if you select it, you can see it will open to this place where you can see all the things we just talked about. You have classification, right? You have regression, you have clustering, and you have dimensionality reduction. So meaning that you can actually use sklearn to do virtually everything in here. And then when you look at classification, you can see all the models that are available in sklearn for classification problems. And regression, you can see all the models that are available. All the models that are available for regression problems. Same thing for clustering, and same for dimensionality reduction. And any model you want to look at here, you can actually select. You can select it and it will open. You can read about it. You can see an example about it, how to use it, and you can do a whole lot with sklearn. And that's one. We'll be using sklearn. Then if you are dealing with computer vision, that's where you want to train your model to be able to recognize images and the rest. You have two main types. You have PyTorch, and you have TensorFlow. These are the two computer vision packages that you can use. So, which is the same thing. If you type PyTorch, you can see that's that torch icon. Select the first one, you can see to take you to the documentation. While that is loading, let's type TensorFlow. So you can see, I open the documentation also. So anything computer vision is, if it's normal models. So if you want to just use normal models, you go with sklearn. But if you want to go with computer vision, you go with PyTorch or you go with TensorFlow. So I think some of these things will be covering more in our sessions. Do we get any question on that so far? Okay, so let's continue. So we'll pick some challenges. So what we're going to do today is we'll try and cover two of the very popular problems, classification and regression problems. We're going to cover those two, and we'll use one or two models from each here. We'll use one or two models from each here, from classification and regression, and then we'll see how you can actually just try out things by yourself. And then see how you can accomplish a lot. So I've opened I think by now everyone should know how to get to this place where you can launch your Jupyter notebook for a given particular, right? I think everyone should have that now. Everyone can do that, right?
Yes, sir.
Okay, so let's go ahead. So the data set we're going to be working on, if you go to this, I have two data sets here. I'll be uploading the data set to the Google Drive so that everyone can actually download it. So we'll be looking at car sales, okay, heart disease, and we'll be looking at how to handle some missing data also, because that's actually very important as well. So the car data set is actually car sales. We are just predicting the price of a car given some features. So that would be a regression problem because it is the price. It is price. It is continuous. Then heart disease. That's whether somebody has a disease or not. So that's like whether someone is positive or negative. So and that's a classification problem. So we'll use those two data sets and we'll be jumping between these two type of problems so that we'll be able to have a solid understanding of how we can actually run all this project. So let's go ahead and let's import some features. So we can start with importing necessary libraries. So importing, you can even make it specific. You can say importing visualization packages. You want to make it specific. So we can import Seaborn as SNS. So we abbreviate it so that every time we need Seaborn, we don't have to type Seaborn always. We can just type SNS and we will have access to Seaborn. So though you can use anything, you can rename it to any other thing, but just that the standard that we use or the one that everyone comes to agree with is the Seaborn. So we can go ahead and also import matplotlib or pyplot as PLT. So those are the two that we need for visualization, and we can import let's say data manipulation. So we can go ahead and import pandas as in PD, that's the standard, and we can import numpy as NP. So all of these are just the industrial accepted standard for importing packages. Then let's look at let's import model. Let's just say model packages. You can actually write this anything that you want. So let's import. Okay, this one we are yet to know which model we'll be using, so let's just leave it. We'll import the model as we need. So let me run this. We import the models that we need when. So that's loading all the model that we just selected. So it's importing matplotlib, it's importing Seaborn, it's importing pandas, and it's importing numpy. So that's why you see the asterisk, and here you can see the loading like those old sound clock. So let's wait a while. So this is why most times I always try to run the code before the class, so that all these delays, the delay of waiting for the code to run or import things, will not have to wait or waste time for that. But today I just wanted us to go through a thorough model development session, and let's try and see how things are being done. Let's see how we make research, we implement, yeah, and that's imported those things. So let's bring in our data set, which are the first things. So the first one, let's create a variable called heart disease, and let's import the data set. So remember PD but the data set is saved as, you can see all of them are saved as a CSV file. So I'll just give it the name heartdisease.csv in this. So I'll say pd.read underscore CSV. Right, so I'm using pandas now. Remember, it's for data manipulation. So you put it in quotes. So I think it's heart dash disease, right? I think .csv. I think that's the data set. Let's bring in our car sales. So let's call it car underscore sales equals to the same thing, pd.read underscore CSV. And what's the name? Let's check. That's in car underscore sales.csv. Okay. So in quotes, car underscore sales.csv. And then, okay, let's just run this. Yeah, so there's no mistake. You can see that's 2. So let's check their head. So let's start with, you can just copy the variable and just paste and say dot head. Remember what dot head does? It shows the first set. You can see it shows the first 5 values that we have. And let's do the same thing for car sales dot head. Yeah, so you can see. So we have two data sets now. So I want to get the difference between classification and regression. So that's the main thing here. So you just need to know the kind of problem you use classification and the kind of problem you use regression. So you can see we have about, these are the main columns, right? And then we have the target. So the target is either 1 or let's see if you can get the tail. Or let's just see the first 10 values. That's, we can put 10 in the head and it will give us the first 10 values. But we don't have any 1 out of 20, the first 20. Well, let's just check the tail since let's just check the tails. The tail. Let's see. Yeah. So you can see. So it's either 1. It's either 1. That's the target now. 1 or 0. I'm not really too sure what 1 represents, but I think 1 should be probably no heart disease also. Then 0 should be no, I think 1 should be heart disease. That is, the person has heart disease. While 0 should represent that the person does not have heart disease. So looking at this type of problem, you already know, or you should know, that this is what? This is a classification problem. It's a classification problem because we are picking between two categories. We are picking between either 1 or 0. Is categorical. So either 1 or 0 is a classification problem. But if we then look at this one, the car data set, you can see when we check the head, these are the columns that we have, right? But then you can see what we are trying to predict is the price. You can see it's a continuous number. It's a continuous number. Definitely. So you then know that, okay, 1, 0 is, we are looking at a classification problem. We are looking at a classification problem. So our heart disease, so our heart disease, let me just make it hard so that we'll make it fast. So our heart disease is a classification problem. But then car now is where what we are trying to predict now is price. So in this case now, it is a regression problem. So let me say car state. So let's just use car. So you get the difference between the two. So one is a classification problem and 1 is a regression problem. Classification is picking between a particular category, and price, you have a continuous values, which is what you can actually see from this. You understand? So some other things that we talked about are, we said you can use .info, .info to check the data types that you have. So we can see that I think all the values here are actually are numeric, and you can do the same thing for car sales. You can do the same thing for car sales also. .info, and it will tell you. You can say object. Remember, when you say object, they are categorical variables or non-numeric. So like you can see make. So make, either it is Honda, BMW, Toyota, and the rest. And color, you can see it's white, blue, and the rest. So it's not numeric. That's why you see it's giving you as object, right? We said you can also check the shape, which will tell you how many values you have. You can see you have 303 rows, and you have 14 columns. Yeah, you have 14 columns. That's the heart disease. And you can do the same thing for the cars. So we don't need to, you can do that on your own. I'll send a data set as well. And then for what else do we talk about? You can use .columns to check the columns that you have. And remember, you can actually assign these columns to, what's that? Oh, so the call will end in 10 minutes. So please, I think you guys are in the group, right? So I will, in Google, I've reduced the time limit for their meeting to 1 hour alone. So just be online. Even if it ends, I will just create another link and then forward it to the group, and we'll continue the class. So let's continue with the 10 minutes. So you can assign this to a variable. Let's just say, let's call it heart underscore columns, and we can set it equal to this. You can set it to columns, and you can use it. Probably you can look through it if you want, or you assign it, or you can use it to do other things. So then we also said you can check .isNA .sum. Remember what we use .sum for. If you remove .sum and you just load it, you can see it's just giving you false. So but .sum will help you count the number of true and false, and then to give us the values in terms of the columns. So you can see we are not sure that there's no missing values in our data set, right? And you can do the same thing for the cars data set also. Do you understand? Do you understand that?
Yes, sir.
Okay. So let's start with the heart disease. So the heart disease is a classification problem, right? So we can go to this place and ask ourselves, okay, now we know the problem. We know that it is a classification problem. So what do? What model? And remember, you visualize, check the data types, check the shape, check if there are missing values, and you try to amend those missing values. And when you are done and your data is set, you do some EDA. And when you are set, you can now decide, okay, now I know what problem I'm facing. I have a classification problem to handle. So which model should I use for this problem? Then if you want, it's just like you are learning. You can go to the sklearn map that we just talked about, and then you can come to this place, start. So we start from here. So you ask yourself, okay, do I have greater than 50 samples? Let's see, do you have greater than 50 samples? Yes, because we just checked our shape. We have up to like 303 data set samples in our data set. So this is yes. If it's no, if it's it is less than 50, then you just have to get more data, right? You have to get more data. But if it's greater than 50 samples, yes, you can say, so you come down, you know what you're kind of like learning. Then predicting a category, you know what it means. It's a category, that is it yes or no, right? Is it yes or no? So you said yes. We are predicting a category, that is, we are predicting either it is heart, whether the person has heart disease or not. So it is a category. So if you say yes, you can see you move to this side. If it's no, then you can see quantity, that's continuous. So if it's yes, it's then asking, is it labeled data? Yes, the data is labeled because we have all the answers given to us. We have all the answers given to us. The answer is the target. So 000 or 111. So those are the answers. So and those are the labels. So we have them given. So it is yes. Then we can move to this side. Understand? So if you don't know how to choose the model, sometimes that's how you just go about it. So you can see if it's no, you can see you are coming to clustering, meaning that it is unsupervised learning. So but in our case it's yes. So we go to this place and we can use any of the models here. You can use any of the models here. You can see it's asking, is it less than 1,000 samples? Now that you're in classification, is it less than 1,000 samples? If it's less than 1,000 samples, then you use things like linear SVC, that's support vector classifier, the CDS classifier. But if it's greater than 1,000, right, then you can go for models like SGD, and use kernel approximation, and say things like that. So the one we'll be using, now, what should we use? Let's look at where's one here. Okay, let's try linear SVC first. Then we'll now try one of these other models. Let's try linear SVC. So I'll select linear SVC. Select linear SVC. Then I can. There's it. Sorry. That's for multi-class. Yeah. So we have it here. So all I need to do is, how I can get that linear SVC is to do what? Is to import it this way. I can say from sklearn, and I will import SVC. Or let me even check it there. You can see, good, this is what I was looking for. You can see the heading. The heading says what? Classification. So SVC, this and linear SVC are classes capable of performing binary and multi-class classification. Binary means it is between, you have those two values, 1 or 0. Binary, that's 1 or 0. Cat or dog, good or bad, pass or fail. You have those two categories. But multi-class means you have more than 2. That's, you have cat, dog, and what else? Cat, dog, and let's say, which other animal do we have? Cat, dog, and I forgot the animal. Okay, let's say cat, dog, and human. Let's see if I want to classify the pictures. So, but multi-class means more than 2. So it's a classification. You have SVC, linear kernel, and linear SVC. So let's just try one of these. So let's start with this one. So we can go to this place. We can go to from sklearn, right? So this is just how you learn. From sklearn, we're importing SVC. So we import SVC, right? That's it. SVM, I mean, support vector machine. Importing SVM. So importing SVM, and then when you import it, we need to instantiate it. So this is what they are doing here. They are instantiating the model. So you are just giving it any name. So this is just a normal standard name that we give to classification model. Is it more than 10 minutes already? Okay, in 2 minutes. Okay, let me just end it. Since in 2 minutes, let me just end it and let me create another link that I can forward to the group chat now. Right? So guys, let me end it. It's going to end in 2 minutes. Let me end it and I'll send the link now. Alright. You see it now in the group. So like we said, so we're importing the sklearn model, right? Now when you import the model, after importing the model, the first thing you do is to instantiate the model, and that is what you always see. You can see they imported the model, right? And this one is just the data set, and then we now have, you can see they instantiated the model, and then you fit it with your data set. So let's go ahead and let's do that. So from SVM, support vector machine, you can bring in the SVC, that support vector classifier. You can see the name classifier tells you that it is a classification model. So let's go ahead and let's instantiate it. So let's give it the name. That's just the variable. So SVM, we're saying from svm.svc. So we are instantiating that. So two ways you can actually do this. Let me add another cell. If you want, you can say from sklearn, right, .svm import scv, import svc. I mean.
We're not seeing your screen, sir.
Oh, sorry. So I thought I was sharing my screen. Yeah, so how about now? Can you see my screen? Hello? Hello?
Yes, we are seeing your screen now, sir.
Okay. All right. So okay, let me just go back then. So I said you import the model, right? So we import it from sklearn. We import svm, and when you import, the first thing you do is to instantiate the model, and the x and y is just your variables. We are going to look at that now. So you instantiate it, and then you can give it your data set. So let's go ahead and let's do that. So we can then give it just a variable name for classifier. So we're saying from svm dot our svc. So, and then I said you can actually do this in two ways. You can do it like this: sklearn dot svm, then import svc. You can do it like this and it will work perfectly fine. Then you can go ahead and say create a variable, create a variable and just call it svc. So you can use these two methods and it will work fine. Whichever one you decide to use is just a matter of preferences. So you can go with this or you go with this. So just remember, if you are importing this first, then you have to use svm dot this, and if you want to go like this, then but let's just use this one. Let's see how it goes. So let's run it. So it's running. It's importing the model. So the model now is named the CLF there means classifier. So that's our classifier model. And if you want to see some of the parameters that are in that model, you can see slfa.get_params. and it will give you, to give you the parameters that are in that model. So later on we are going to look at all of this, the parameters and tuning all these parameters and the rest. So let me remove this. Let me just cut this out. So once you instantiate this, the next thing now, if you look at this, you notice that they first of all have x and y. It is that x and y that is being passed into our model. So what x and y actually is like our data set now, which we are dealing with, is the heart disease data set. Now every other thing here, age, sex, CP, all the way down to this tau, that's TL, are the x values, while the target is the y value. So the target is the value we are trying to predict. That's what the target is the value we are trying to predict. So the first thing we do, or we can do, is to first of all split our data set into x values and our y values. So let's go ahead and let's do that. So how we do that is, let's say x is equals to, let me just copy this variable, that's heart disease. Let's say heart disease dot drop. So that we'll just drop, we can say columns. We say the column should be that's what, which column? That should be target. Yeah, that should be target. So we are dropping target, and then we say axis equals to 1. Remember in our last class we said two things. You have axis. Axis can be 0 or 1. So when you say 1, it means the column. Axis can be 0. Axis can be 0 or 1. Please, can you mute yourself? So axis can be 0 or 1. Axis can be 0 or 1. So if it's 0, it means that's the row. And if it is 1, it means the column. So what we're trying to do? What we are trying to do is, we are telling it to drop this particular column as target. So if you could look at our data set, just drop this target, and every other thing here from tau to the age, assign it as x. That's what we're doing here. And then we can then say y should be equals to the target now. So let's run this. Now if you check y.head, you can see y is only just 111 or 000. I think if you check .tail, you should see the 000. Yeah. But if you look at x.head now, if you look at x.head, you can see x is just these values without the target. So y is what we are trying to predict, right? And x is the remaining data set. You understand? So that's what we are trying to do. Let me cut this away. Yeah, so we've done that successfully. So the next thing now is, we need to split the data set now into training and testing sets, so that we can use, like we said in previous classes, that you split your data set, right, into training and testing sets. So most of the time you use like 70 to 80% of your data set for training, and you then use like sometimes 10 to 15%, yeah, sometimes 10 to 15% of data set for testing, testing, and sometimes you have another one which is called validation set, for validation. So we use this for fine-tuning the model. But we're going to, let me say 20, 10 to 20. Well, it all depends on what you want to do, or how. Some people use 10 to 15%, some use 10 to 20%, some use 70 to 80%, or 80 to 85% for training and testing. Well, it all depends on how much data set you have and what you're trying to build. So in this case, how you do that, or how you split the data set into training, is with a tool from sklearn. So let's import that tool. So if you don't even know the tool, you can just go to Google, right? Let's do as if we are trying to learn. Let's go to Google and let's say splitting data set into train and test set. And okay, let's put, maybe it doesn't show, but let's just put let's put sklearn, and let's see what it will give us. So can you see it? sklearn gives us something. sklearn.model selection train test split. So you know that, okay, if I want to split my data set, what do I need? I need this train test split function to help me split my data set. Right? I don't know if you are getting. Then you can say, okay, what does it take? It tells you that it takes an array. An array, that's your data set. So arrays, that's your data set. The test size, that's what size. Do you want 20%? Do you want 10%? Do you want 5%? Then train size, random state, or shuffle, right? Or stratify. Stratify just tries to like balance the number of, like here we have 1, 1, 1 and 0, 0. So it tries to balance the difference between those. And you can read, okay, what's the arrays they are talking about, and what's the test size they're talking about. And so it's telling you that it's either float or integer, right? And they give you an example. Same thing for this: random state, shuffle, and stratify. And you can see an example down here. You can see an example. So that's how you learn if you don't know how to use a particular tool, or you are new to a particular tool. So let's go back and let's continue. So from there I can know that, okay, to split my data set, I need, where is it? I need this model, I need this function, train test split. And where can I find it? From model selection, which is inside of sklearn. So I can go back here, I can say from sklearn dot model underscore selection. So, but I've been using this for long, so I know that, okay, so you just get used to it after using them for a while, right? Now, how do I use it? It takes 4 variables: x train, right? Y train. Remember, I'm separating the comma, and then you have, x test, y train, and you have y test. Then I can call this function. And then give it, the first thing it says what? It says is the arrays. The array, which is the x and your y data set. Those are the arrays. Your x and your y data set that we've created here. And then the next thing it says, you can give it a test underscore size, which, what do you want to, how many percent should we use here? Let's use 20%. So that's 0.20. And then we can look at random underscore state. So the reason why I know all of this is because I've been using it for long, so I already know what to give to this function, and I know the variables to create here. So you can see you have the x train, the x test, you have y train, y test, and then you call the function, you give it the 2 arrays, which is x and y, that you've created, the test size. When you give it the test size, you don't need to give it the what again? You don't need to give it train size again. But once you give it the test size, if it's 20%, it automatically knows that, okay, the remaining 80% goes for testing set. So that's why I need to specify the training size. And these other parameters, it's not a must to use them, right? If you want, you can use. So all of these values are the default values. By default, shuffle is true, it's set to true. So it definitely is going to shuffle my data set, so I don't need to pass in the shuffle. And this by default is none, so but I don't actually necessarily need to use it now, so I can leave it. So I'll hit run, right? So once I hit run, I can give these values now to my model to learn. So I can use SLF.fit. So fit means train the data set. Like let's see our sklearn. You can see fit, and then they are giving it x and y. So we are not giving it the entire x and y because we want it to learn and they want to use it to make some prediction. That's why I'm splitting it. So we are going to give it x train and y train. Right? X train and y train. Now we can run. So now our model has trained already. Our model has trained, right? And we can actually run some prediction now. We can try to look at SLF.predict, and let's pass it our X test so that we can see how well it is performing. X test, let's call it predictions. Let's do that as a variable. Predictions. And let's print it out and let's see what it would look like. So you can see our model has been trained on training set. We are now giving it a test set to predict so that we can see how well it is doing. So we are saving that prediction into a variable called predictions, and we are calling the values in the variable. Let's see what we have. So this is what our model is predicting. This is what our model is predicting. So to actually see and compare, let's bring in y test, because what the model predicts should be equal to what is in y test, because we are giving it x test. So let's print y test here and let's see. So you can see the first value that was predicted is 1. Here is 0. Here is 1, 1. You can see our model is not actually performing well. And we can check that by using the score function, slf.score, and the score will give it x test, comma, y test. And you can see that it's printing out 0.55. So what it means that is 55%. So that's what the score function is doing. So it's scoring her. And if you look at it, it's actually true. Why? Because see, the first value was, instead of 0, our model was predicting 1. Yes, it got the second value, but you can see most of other values are actually wrong. The last value here is 1, and the last value here is 0. So the model is not really performing well. So if you check the score, you can see it's telling us that it's 0.55. If you multiply by 100 to give it in percentage, which is about 55%, or you can approximate it to 56%, but still the performance of that model is actually very poor. So if a model performs very poor, what you can do is to try to choose another model. And let's go here. So you can see we use SVC model. It performs very poor. We can choose to use any other model here. Let's look at this Ensemble classifiers. So what Ensemble classifier is, let's look at what it does. The goal of Ensemble methods is to combine the predictions of several Bayes estimators. So what Ensemble means is combination of more than one. So instead of just using one model like this SVC, Ensemble will combine maybe like five of these models together, or 5 of different types of models together, and it will be able to learn much better than that. So let's just go ahead and let's bring in one 1 from that. Let's see what we have. And you have different types. You have bargain classifier, k nearest neighbor. You have forest. Okay, let's use this random forest classifier. So let's go ahead and let's import it. So same thing, from sklearn.ensemble. You can say from ensemble, and we can import random forest classifier. Yeah, I think that's it. And remember, when you import it, the first thing you do is what? Is to instantiate it. So let's say cf_2, since it's the second classifier model. You can instantiate it. Remember, it's just record the name, right? Close and open bracket. So let's go ahead and let's do everything at the same time. We can use the clf_2.fit. Can fit, we give it our x_train, comma y_train, right? And let's go ahead and let's score it. So cl_2.score. Let's give it our x test, comma y tests. Let's run it and let's see. So you can see that we're actually doing the same thing. For the SVM, we imported it, right? We instantiate it. We gave it our x train and y train, that's .fit, and we did a prediction, right? We did prediction and we did the score. So it's the same thing we actually did here for the random forest. So, but you can see the difference. This is 0.75. This one was, where is it? This one was about 55%. Okay, let's try the prediction. So let's call it spread. Let's call it spread, and that will be clf_2.predict x_test. So let's print the predictions now. Let's print the predictions. What's happened? Okay, and let's print our y_test now. Let's see. You can see that the model is performing 75% now. You can see that it's doing much better. The first value is 0, predicted 0. Second value is 1, predicted 1. The next value is 0, 0, 0. You can see it's 0, 0, 0. Are you getting? Though it's still making some mistakes. The last value here is 0, the last value here is 1. But it's performing better than this model, right? Which was performing worse, about 55%, while this one is performing about 75%. So sometimes that's what you do. If you use a model and you see that the model is not performing well, you try to use another model. Remember, the model have to fit the particular type of problem you are dealing with. So we are dealing with classification, so we're only using the models that are available in the classification arena. So we use this SVC, gave us bad performance, and we tried example method, right? So even this example method is still using SVC, but it's using multiple of that SVC combined together. It's using multiple of them, not just one. And you can try k neighbor classifier. You can try this one and see how well to perform. You can try this, try any of this one, and see how well the model will actually perform. But you can see that example method actually gives us a better result than what the other method is actually giving us. Do you understand that? Do we understand? Or if you have any question? Okay, no question. Okay, let's continue then. So, before we then look at the regression one, so that we can try some methods in the regression aspect also and see how it works. So with the more we do one of these or two of these from here, you can have a solid understanding, okay, how to actually use some of this model in a particular problem. So we've tried like two methods in classification, right? So one last thing before we go to regression is sometimes we want to see how well our model is performing. We've used score. Score is giving us, let's say, like a percentage value that we can use to differentiate between two models. This one was giving us 55%, this one is giving us 75%. So sometimes you want more than just that. Okay, sometimes you want more than just that. So to be able to look at some metrics, you can still check sklearn to get a good understanding of, let's say, the metrics that you should use. Now, the same thing for metrics. The metrics you use for classification problems, is different from the metrics you use for regression problems. Do you understand? So for classification problems, you can be using things like accuracy, precision, recall, and the rest. But for regression, you'll be using a different set of metrics, which are things like absolute mean error, root square mean error, and other things. So if you want to even understand more, you can just type sklearn metrics. Type sklearn metrics, and you can see we have metrics. So if you select this, you can see we have different metrics here. You can see there's classification metrics and there's regression metrics. So if I select classification metrics, you can see you have a lot of them. You have precision, you can see ROC curve, confusion matrix, and the rest, F1 score, and a lot of them classification reports. So let's just apply one or two and let's see. So let me scroll down if there's an example, and let's see. So you can see an example from sklearn.metrics. We import accuracy score that we can use it. So in fact, I'll just go ahead and just copy this because it's the same thing we are going to be typing. So I'll just paste it here, right? And I'll just use the function. So see what happens. I'll just copy the function, and then I'll give it my X test and the Y test, and let's run it. Classification metrics can handle. What are we trying to predicting? Okay, let's try using what did I give it? Okay, sorry, I'm supposed to give you the prediction, not. I'm supposed to give you the prediction. So here's supposed to be Y test, right? Y test, and what do we have? Let's use spreads. Yeah, spreads, and let's see. Yeah, you can see it's giving us. You can see it's showing us the same thing, accuracy score. So if you go here, you can see accuracy score. So if you call the function accuracy score, you have to give it the Y true. That's your Y test, and give it the Y pred. That's your predictions. So I think the mistake I did there was giving it a test instead of the predictions that we made. So you can see printing out 75. I think I can multiply this by 100, and it will give me 75. So, and we can try one more. So we can say, let me see if I still have. Okay, I don't have. This is from sklearn.metrics. I can call metrics, and I will import classification. Yeah, classification reports. That's underscore report. And if you want, you can even import confusion metrics. Yeah. So if you want to import more than one package, you can just separate them by comma. And if I bring in, let me say print, and I call classification report, let me just copy it and paste. So I call the function now classification report. This one will have to give you the Y test and the prediction. So that's spreads. And you can see to print out a report. So So it's giving me the precision, recall, F1, and support. In the next class, we're going to cover in depth what precision, recall, and F1 scores are. So, but you can see what we have. Accuracy is still here. You can see it's still 75%. So if you want more in-depth knowledge on the metrics that you can use, depending on the problem you are facing, you can use different metrics here, and you always see an example of how to use them. And it's always very clear. All you have to do is just, okay, let's try this confusion matrix. I think so. We'll call confusion matrix, give it a y true. So we've imported it already. Yeah, so I can just copy the function. To the function, give it. So let me just grab this, because it's the same thing. The y test and the prediction, and let's see. You can see. Though it didn't plot it as this because I have to do it special for it to plot it, but you can see the values. You can see it's giving us as that matrix. So it's actually very straightforward to use all these tools. It's just straightforward. So any question on that? Any question? Sorry? Okay, since there's no question, so that's classification. That's classification problem that we just covered. So you should have a solid understanding of how you can tackle this sort of problem. So let's go ahead and let's face our car challenge, and let's see how we can handle regression. So even regression is very much similar to. So the first thing we do is to let's split. Okay, let's first check if I think it was car underscore sales, right? Let's check if there are missing values. There's some. Okay, there are no missing values. There are no missing values in our car sales. But the only problem with car sales now is dot head. Car sales does not contains all numeric values. We have categorical values as well. That's make and color. Understand? So that's if you use car underscore sales dot info. Let me see. Make is object, color is object. That is their categorical. So we need to handle this first before any other thing. So, but we can go ahead and split our data set into X and Y, because what we are trying to predict is Y, which is the price, and the remaining values are X, so which we can actually deal with. It's the same thing we are doing. So we create our X, and we call the car underscore sales, right? Dot drop. We're telling it drop these columns. Where's the column? We are dropping just the price, and we're telling that the axis is 1. That is dropping the columns, and then Y can now be car underscore sales, which is the price. Right? I think if we run it, let's see X dot head. Yeah, so you can see there's no price in X because it has been assigned. Right? Because it has been assigned. Price now has been assigned to Y because it's what we are trying to predict. And the other columns now are now assigned to X, which are the variables that we need to manipulate to give us our prediction. So how do we now turn all of this into numeric? Because our model will not understand. If you pass this now to our model, it will not really understand what you are giving it. So how do we turn this to numeric values? So if you don't know how to do it at first, let's say you are new, you can actually check on Google how to convert to convert categorical categorical data to numerical data in Python. So you can see create dictionary and convert them into data frames and use get dummies. We discussed get dummies in our previous classes. If you recall, then or if you want, you can even make it specific. You can say numerical data, and then you can put sklearn, because sklearn has virtually all the tools that you need to do all the. So you can see, if you check very well, you can see sklearn dot pre-processing dot label encoder. Let's select it. Now you can see you have all the tools available in sklearn to actually start experimenting. You can see encode target labels with values between 1 and n classes. This transformer should be used and the rest. So you can actually read. You can see you have ordinal encoder, encode categorical features using an ordinal encoder scheme, or one-hot encoder, encode categorical features as a one-hot numeric array. So if you select, let's say, one-hot encoder, to tell you how to use it, you get it from pre-processing, right? And if you scroll down, you should see an example being shown. You can see you are importing it from sklearn, and then you are passing it the values, and you understand. So let's just try and implement it in our lesson. So let's go ahead and let's import that one-hot encoder. We'll still use other method though, but let's try and see. So from sklearn pre-processing, and we're importing what? We're importing one-hot encoder, right? And let's import something else. Sklearn dot compose. From compose, I will import. I'm going to show you what this one does. I import column transformer. I'm going to show you what this one does. So let me go here and let's see column transformer sklearn. Yeah. So you can see you import it from compose. So apply transformers to columns of an array or pandas data frame. So what it means is that if you want to apply, let's say, you want to convert some columns to numerical, what we are using it is, if you look at our data set, it's not just one column that is categorical. Make is also categorical. Color is also categorical. So what you can do is, instead of picking one column at a time to apply transformation to it or convert it to numerical, you can use this class or this method, column transformer, and apply everything to the entire columns that you want to convert, instead of making it one after the other. So with that, you don't have to start selecting one column at a time. You can just pass it all the column and it will implement all the functions that you want. So you can see transformers, you can see name, transformer, and then the columns. You can see the columns, and to go ahead and to convert. And if you scroll down, if you see an example, yes, you can see, you always see an example, and you can try to apply it. So let's apply it to values. So I'll say cat features. So cat features means categorical features, and I'll create a list that's make. I'll use make, and then I'll say color. Right, so I'm giving it the two columns that are categorical, under and make and color. So those are the categorical variables, and I have to instantiate our one-hot encoder. So remember, instantiating it is just to give it a variable name, call it, and pass in the open and close parentheses. So I can then create my transformer, that's transform, and then I'll call this column transformer now. So what the column transformer does or takes is, if you look at what it says, is, where is it? It takes the transformers. So first is the name, right? First the name, and then you have the transformers, which could be a list of tuples. So you can see name, transformer, columns. Let's go ahead and let's include that so that you can see what we're doing. So to take a list, so the list, that's square bracket, and to take a name, that's, let's call it 1 hot, that's the name, comma, then the transformer itself, which is 1 underscore hot, that's this transformer, and then it takes the columns. And what are the columns? We call the columns cat features. So I just copy the name and I'll paste it here. And we can tell it that, okay, the remainder should be passed through. So what the remainder means is, remember, you are giving it, is going through this data set, right? So you told it make and color. So to go through make, convert it to numerical, go through color, convert it to numerical. But what of the remaining data set? What should we do? So we're just telling you, okay, just pass through those ones. Don't implement any change on them. So we can now say, okay, new x, that's our new x value now, should be transform dot fit underscore transform underscore transform fit underscore transform. Then we pass it the x value, which is this x. That's what we are converting. So let's just print that x and let's see what it is. So let's run it. Error, 1 hot encoder object is not iterable. Here's the problem. Okay, I need to put this as tuples. So because if you look at the example, where is it? If you look at the example, there's a square bracket, then there's the open and close bracket. You put the name, you put the function you want it to do, right, and then you give it the columns that you want it to work on. So now let's run it and let's see whether it will work. Yeah. So you can see it has converted everything to numerical values that we can now use for our model. You understand? So now we can actually split it now using the train test split. So let's go ahead and let's do the x train, x tests, y train, y tests, and then we can call our train test split. Remember, this one we already imported it from up there. Yeah, we already imported it, so we don't need to import it again. We can just call it at any time. So x, y, and we can say our test size should be 0. Let's use 20%, and let's look at the random state. Let's just set it to be 1. I think that's just all we need, and then we can go ahead. We can go ahead and we can fit it now. So have we imported our model? No, not yet. We've not imported our model. So let's look at the model that we'll use for this. So what model should we use? Where is that model? Where are we choosing model? So let's look at this. So we have regressor, we have SGD regressor, we have lasso, we have Example regressor. So let's just go straight to Example. Let's go to Example. So in Example, we can go sklearn.example import. Oh, why are we seeing classifier? Sorry, not classifier. It's supposed to be regressor. So let's select this. Now it's still showing classifier. Why is it still is showing classifier. It should load. Okay, probably you checked that, but it should load regressor. But don't take time and start going to so regression, yeah. So regression, we cannot check the models, but if you go through it, as classifier has example method, regress also has its own example methods that you can actually use. So let's go ahead and let's just import one of them. So let me run this cell and let's import one of them. So let's say from sklearn, let's dot example. We're still using example, and let's import. Let's still use random forest, but this time around now we're going to use what? Regressor. Random forest regressor. We can instantiate it. Let's call it model. Instantiate it. Remember, we just call the name, right? Open and close bracket, and then we can say model.fit, and we pass it our X train and our Y train. Let's run and let's see. So you can see our model have run successfully. So, but how do we know if the model is actually performing fine or if the model is actually performing well? So we can check for metrics. So let's go to metrics. I think we open metrics one time. Yeah, metrics. Let's go to regression metrics. So regression metrics, there's R2 score, there's mean absolute error, right? So let's import this one. I'll just go ahead and just copy it. Now paste it there, and let's see how to use it. So how do we use it? So we just call the function, give it y true and y prediction. You can see the whole thing is just doing, we are just doing almost the same thing. Okay, we have 10 minutes here also left. Okay, yeah, this is just the last part. So we are doing the same thing also. Let me add a cell here and let's make some predictions. So let's say spreads, and let's call our model dot predict, and let's give it an X test. Let's run this. So our y true will be the y test, and our y spread now for we it is just spread with an S. So let's run it and let's see. You can see. So wow, this is high. The error rate is very high. This is about 5,817. This is the mean absolute error. The error rate is very high. So we can try other methods or even try to change some other things there to actually improve the accuracy. Now, so there's another one, mean square error, which you can actually use. Still the same thing, you're giving it y true and your prediction after importing it here. You have mean square logarithmic error. You can see you're still doing the same thing. Understand? So that's just the idea behind. So we've been able to look at we've been able to look at classification models and regression models. So in the next classes we'll be looking at clustering and dimensionality reduction situations. So a wrap up of this, you know what classification is, you know what regression is. So classification, when we're trying to predict within a given set of category. So and classification could be binary or multi-class. And regression, when you're trying to predict a continuous number. So like somebody's salary, the age range in a class, and the rest. So the remaining 10 minutes, let's see, okay, or 8 minutes. Let's see if there's any question. So, but I'll be sending this notebook. Let me call it. Okay, let me just call it fresh class so that I won't forget. So I'll be sending this and the data set as well. Plus the video, I'll be uploading it to the YouTube channel that we use. So I'll post it so that everyone can go there and either download it or watch it, whichever one you prefer. So any questions so far? If there's any question, let's ask.
For now, thank you so much, sir.
No problem.
For now, maybe not, but when I go through the exercise again.
Okay, no problem.
Please, in the next class, are you going to deal with reduction?
And yes, we should be able to cover that clustering and reduction. So, but the idea is even the same thing. The idea is the same
yes.
thing. The way, but just as some tricks, and then we'll just cover some of those tricks and see how it's being done.
Okay, sir.
Okay, so in the absence of any questions.